All right, welcome. Today, we're jumping right into how to build AI that doesn't just wait for you, but actually thinks for itself. We are going way beyond the simple chatbots to build systems that are truly autonomous, ones that can plan, act, and smash their goals all on their own. Let's get to it. You know, this quote just nails the huge shift we're talking about. It really is the difference between a passive tool and a proactive, goal-seeking system. Think about it. A chatbot is basically a fancy search bar. It just sits there, waiting for you. But an AI agent? That's your problem solver, your autonomous worker that's actively chasing an objective. This is the leap from just having a conversation to actually getting things done. So what exactly is Agentic AI? Well, to put it simply, it's all about designing systems that don't just give you an answer, but actually achieve a goal for you. These things can create their own plans, they can execute a whole series of steps, and they can use tools to interact with the world around them, all without a human needing to micromanage every single action. They think, they plan, and most importantly, they do. So here's our game plan for this explainer. We're going to start by moving past the whole chatbot idea. Then we'll get under the hood and look at the core architecture of these systems. We'll explore the two main flavors, single-agent and multi-agent systems, see how they're being used in the real world, and then we'll wrap up by looking at what this autonomous future holds. Okay, first things first, we have to establish why we even need to move beyond the chatbot. Because this isn't just a small upgrade we're talking about, it's a completely new category of AI. It is a genuine agentic leap forward. The key word here, the one that changes everything, is autonomy. Look, if your goal is to automate a really complex data science workflow, or maybe orchestrate your entire enterprise system without creating a ton of human bottlenecks, you absolutely need an agentic architecture. These are systems purpose-built for goal-focused tasks. Fetching data, using tools, and making decisions in real time to get the job done. So, the big question is, how do we actually build one of these? Well, it turns out that every agentic system, from the simplest little bot to the most complex network, is built from the same set of core foundational pieces. This is the blueprint for the autonomous mind. This right here breaks down the 4 pillars of any agentic system. First, you've got your development framework. Think of this as the toolkit and the set of instructions you use to build the agent's logic. Second, you need an agent runtime. This is the actual digital world where the agent lives and does its work. Third, you need agent tools, like APIs. These are basically the agent's hands, letting it reach out and interact with the world. And of course, at the very heart of it all is the AI model, which acts as the brain, the core reasoning engine for the entire operation. All right, let's look at our first major architectural pattern. When you have a really precise, targeted task, you can think of a single agent system as a kind of surgical instrument, a scalpel. The idea here is really clean and direct. You have one agent, it's powered by one AI model, and it's given a very clear mission and a specific set of tools. Its entire job is to take a request and see it all the way through to the end by creating a plan and then executing the steps. It's focused, it's efficient, and it's built for a single, well-defined purpose. So, when would you use this scalpel? Well, it's perfect for tasks that have a clear, logical path, even if there are a bunch of steps, like, say, a customer support agent that needs to query a database to check on an order status. This is exactly why it's the recommended starting point for anyone who's building their first agent. A simple development kit and a cloud runtime is the go-to architecture for prototyping and testing out your first autonomous system. But what happens when you have problems that are way more complex, the kind that span multiple departments or systems? Well, for that, we need to move from a single tool to a whole collaborative team. We need to build an organism, a kind of nervous system for the entire autonomous enterprise. And this comparison chart really lays out the trade-offs perfectly. A single agent system is simple, sure, but it can get pretty clunky and hard to manage as the tasks get more complicated. A multi-agent system, on the other hand, is built from the ground up for that complexity. By breaking down a huge problem into smaller chunks for specialized agents, you create a system that's way more scalable, it's more robust, and it's a whole lot easier to maintain and update over time. Now, the simplest multi-agent pattern is called sequential. And it works just like an assembly line. It's absolutely perfect for those highly structured, repeatable processes. You have one agent that extracts the raw data, it passes it off to another agent for cleaning, which then hands it off to a third agent for loading into a database. The output of one step just becomes the input for the next. It's predictable, and it's super efficient. Then you have the parallel pattern, which is all about speed and getting multiple perspectives at the same time. Here, a single request gets fanned out to a whole team of specialist agents that all work at once. So, for example, if you're analyzing customer feedback, you could have one agent looking for sentiment, another extracting keywords, and a third trying to figure out the urgency, all of them processing the exact same text simultaneously. Then, a final agent pulls all their findings together into one comprehensive report. This approach dramatically cuts down your processing time and gives you a much richer analysis. Okay, so we've covered the theory, we've looked at the blueprints. Now let's see how all this stuff actually works in the real world. How are these patterns being applied right now to solve some major enterprise challenges? Here is a seriously powerful application: democratizing data science. Instead of needing a whole team of experts to write really complex code, a multi-agent system lets a business analyst just ask a question in plain English. The system then takes over, orchestrating the entire workflow of querying databases, running the analysis, and generating the insights. It's a game changer. And this is what that AI team looks like under the hood. You've got a root agent that acts like the project manager. It takes the user's request and delegates the tasks. Then you've got an analytics agent that handles the heavy lifting with Python code, while other specialist agents, built for different databases like BigQuery or AlloDB, go and get the data. It's a perfectly coordinated team of specialists, all working together on the same goal. Another massive challenge for any big organization is just making sense of all their unstructured multimodal data. I mean, how do you find one single verifiable insight from a chaotic mix of images, videos, text files, and server logs? A multi-agent system can do this. It can deploy a specialist for each data type, have them each analyze their piece of the puzzle, and then bring all those results together into one high-confidence conclusion. This is how you find the signal in all that noise. So how do you pick the right pattern for your problem? This decision matrix is basically your playbook. If your workflow is predictable and linear, a sequential or parallel pattern is probably your best bet. If it's really complex and needs dynamic planning on the fly, you're going to need a coordinator or a really powerful single agent. For tasks that need some trial and error or refinement, you can use iterative patterns. And, this is critical, for any high-stakes decision, you absolutely must build in a human in the loop for safety and oversight. This is how you match the right architecture to the mission. Whew, we've covered a lot of ground, from the core concepts to the architectural blueprints and real-world examples. But the main takeaway is this: building truly autonomous systems is not science fiction anymore. The tools and the design patterns are here, right now, ready to be used. So, I'm going to leave you with this one question to help frame your own work. The problem you're trying to solve, is it a single, well-defined task that needs the precision of a scalpel, or are you dealing with a massive, interconnected challenge that requires the coordinated intelligence of a full-blown nervous system? The answer to that question will guide your path to building your own autonomous systems. Autonomy really is the ultimate goal, and believe me, we are just getting started. In our next explainer, we're going to dive deep into how these agents can be supercharged with generative AI, giving them access to huge lakes of your private data so they can provide real-time, actionable context. Thanks so much for joining us, and stay autonomous.